Okay, so let's go over the green regression SAT and GPA example. Okay, so really quick, an overview of this context first. This data set is just to see if your SAT score or maybe your ACT score in high school might be a good predictor of your GPA your freshman year of college. Okay, so before we get too deep into it, do you think that that might be a good relationship? What do you guys think? Just based on yourself, based on people that you know, do you think the standardized test that you take while you're in high school, maybe junior or senior year, is going to be a good predictor of the GPA that you get your first year at college? Okay, why? Okay, I could be dumb now or smart in college. What else? Yeah, so if you are just not a great test taker, you might not get a very high score, but you're a dang hard worker. You're going to do all of your homework. You're going to study for your like little chapter tests, and those are different. When we say, generally speaking, when people say I'm not a good test taker, you do okay on like chapter tests in a certain class because you can study for it and prepare, but that whole standardized test where it's like, here, just come answer questions about everything you've learned since 5th grade, that's a little different. Okay, well, the correlation is actually 0.45 in this data set. What does that number tell us? Yeah, kind of like what we were just saying. It's not really a very strong relationship. Okay, we're not going to be able to make amazing predictions about your freshman year GPA based on your SAT score from when you were in high school. Okay, the relationship just isn't close enough. There's a lot of other factors that play into how well you're going to do in college besides just your standardized test that you took in high school. Okay, so let's start. I'm just going to put this data up on the board really quick. Okay, so in this data set, I didn't realize it was just your math SAT score, not your overall, but it doesn't matter. So the average SAT score from the people they collected this data from was 510 with a give or take or an SD of 80 points. And then the GPA, their freshman year of college, the average was a 2.9, give or take about 0.4, okay? With an R value of 0.45, which we kind of talked about. So the first thing that it asks us to do is estimate the GPA given some SAT scores. Now, we have two ways that we could do this, okay? This is one of the things that Karanda taught you initially. We also went over it last class. I am going to go through both ways today just because I think it's good for you to see it and kind of think through it both ways. But I'm telling you right now, from here on out, if you never do what I'm about to do ever again, and you always just rely on the regression line, that's fine. Okay? I just want you to see it this way one more time because it will help you understand some of the other questions in the packet. Also, if we jump right into the regression line right now, then it's going to feel a little stupid when in like 6 more questions it asks you to find the regression line. Okay? All right. So let's think about this first question. If the SAT score for a particular person is 430, we are trying to predict their GPA. So earlier, Jackson asked a question about how do you know which one is X and which one is Y? Okay, the answer to that is you have to understand which of those two variables would be your explanatory variable and which one is going to be your response variable. So which one seems to cause the other, or which one seems to affect or have an impact on the other one, okay? Sometimes it's a chronological thing, like we say that a father's height is the explanatory variable when we're talking about his son's height because the dad came before the son. I could look at a son's height and make a guess about the father's height, but the father's height would be technically the explanatory variable in that case, okay? In this situation, which came first, the SAT score or the GPA? The SAT score, because they're talking about your college GPA. SAT is something you take before you get into college, okay? So just because of time, it makes more sense for that standardized test to be the predictor of the GPA, yeah? Which would make this X and this Y. The SAT would be X and the freshman GPA would be Y. Also, what was the other pro tip I gave you guys last time? Do you remember? I have yet to see a problem from UVU or out of this textbook where the explanatory variable wasn't the one listed first or on top. Okay? So if you can't figure it out, X is the top, Y is the bottom. Yeah? Okay. So if I know that a person scored 430, what can you tell me about that person? Based on the information that we have, what can you tell me about a person that scored 430 on their SAT? That they are below average. Do you agree? Okay. So the first thing I want to do is figure out exactly how far below average. The fastest way to do that is just to rely on the good old Z-score formula. So if my Z-score for this SAT score is that value minus, what is the average for SAT? 510 divided by the standard deviation for SAT, which is what? 80. And what do I get when I do that? What's 430 minus 510? What is it? Negative 80. So then negative 80 divided by 80 is what? Negative 1. What does that negative 1 tell me? This person's SAT score is what? 1. Standard deviation below average. Yeah. This is what your Z-score is. So basically what I'm doing, my first step here is to subtract these. I want to figure out 430 is how many points lower than average. Yeah? It's 80 points below average. Well, because the size of the SD is 80, when I divide that, it tells me that that person's SAT score is exactly 1 standard deviation below average. Okay? Now, listen carefully. Does that also mean that their GPA is 1 standard deviation below average? No. Okay? The only time SATs or the only time SDs work like that is on the SD line, and we don't use that. Okay? We only use that when they specifically say, is this point on the SD line? Or use the SD line to do this, but the SD line is trash. Okay, we don't use it for making predictions. It's not a good measurement of our data because the SD line assumes a perfect correlation. Is this perfect? No, it's not even halfway perfect. Less than half perfect, 0.45. Okay, it's not good. So if we use the SD line, then we're going to get numbers that are way off. So we can't do that. So what you have to remember is that for every SD on the X variable, so this is X, right? The SAT score. For every one SD off of the data in the X variable, the Y variable is going to be exactly R SDs off of average. Okay? So because this was a -1, I am going to go down, because it's negative, I'm going to go down this much of this SD from average. Okay? So you could just say their GPA then is going to be average, and I usually put a plus sign right here. In this case, we know it's going to go down, but my R or my Z score will take care of it. So I'm going to have my GPA plus my Z score from over here, and then R SDs of Y. So this is, I guess I should have just done it. Look, I'll just do it this way. So this is Y average plus the Z score from the X's times R times the SD of Y. Okay? So in this situation, R is 0.45. And what is the SD of Y? 0.4. Making sense? Yeah? Okay. So if I multiply that all out, I get 2.9 minus what? What's 0.45 times 0.4? Point what? So if the question is, what freshman GPA do we expect from a student whose SAT score is 430? Then our answer is a 2.72. Do you understand how those variables work together? Yeah, so instead of going down an entire 0.4 on the GPA, I only go down R times that much for every SD below or above average over here. Okay? So what do you do with 510? Yeah. And what is the Z score for 510? 0. So how far off of average is their SAT score? It's not. It's not off of average. It is average. So what GPA do we expect? The exact thing, the average. Okay? So you don't really have to do any math there. And then let's do the 700. Okay, so if the score is 700, we want to find the GPA. So what do we do first? Yeah, we figure out how far 700 actually is from average. Okay? How far is 700 from the average, which is 510? So I'm going to find the Z score for 700. So 700 minus average divided by SD. Is 700 above or below average? Above, like quite a ways above, right? So if it's above average, we're also going to be expecting a GPA that's above average. So just something to think about before we proceed. We also expect the z-score to be a positive number this time. So we have 190 divided by 80. Is that correct? And what does that give us? $375. Okay. So we expect a GPA that is R times 2.375 times 0.4 above average. So our GPA, or our predicted GPA, I guess, should be average plus there are 2.375 standard deviations. And we're only going to take R for each one, or RSDs for each one. So 0.45, and then the SD is the 0.4. Okay? So if I was on the SD line, I just wouldn't have this number in here. 2.375 SDs would be met with 2.375 SDs. But because I'm looking at the regression line, the line that actually helps me make predictions, I multiply it by R, which makes a much lower, much less extreme prediction. Throw that on the calculator, and what do you get? The expected GPA is, anybody? 3.3? 3.33? Okay. 3.3275. So if we round that to a GPA, that would be what? 3.33. Good? Okay, cool. All right, next question asks you to just plot your regression estimates. It's basically just asking you to make a coordinate plane, okay? But the biggest piece here is understanding that those 3 dots should make a straight line. They are all located on that regression line, okay? So really, it would be that dot that was average, so like the 5, 10, and the 80 plotted together. And then you would have a dot where? At 430 and 2 point, wait, why did I put 80? I have not. Oh yeah, because that's average. Wait, what? 5, 10, and 2.9. Guys, you have to stop me when I make mistakes. So this is SAT, this is GPA, right? So 5, 10, and 2.9, that's one ordered pair. One SD below 5, 10 at 430. We went down our SDs, so just a tiny bit to 2.72. And then over at 700, so clear over here somewhere, we had a GPA of 3.33, which is up here somewhere, so that when we connect them, they're all connected, okay? So those are just 3 dots that are kind of a sample, I guess, of all the ordered pairs that could be a part of this data set. But those are not necessarily all in the data set. So those dots don't tell me that there has to be a person from that data set, like from the people where that data set was collected. There doesn't have to be a person that scored a 510 and got a 2.9. There also doesn't have to be a person that scored a 430 and has a GPA of 2.72. There also doesn't have to be a person that scored a 700 and has a GPA of 3.3. Those are just predictions based on the other dots. So these numbers come from the fact that there are dots all over the place. There's lots of variability. We know there's lots of variability. How come? How do we know there's lots of variability? The R value is 0.45. It's not super, super strong. So the dots are kind of all over the place. There's some high and some low. We could have points over here. We could have points over here. Yeah? Will there be any points that are actually on that line? What do you guys think? Yeah. That just means that some person in the data set actually has the GPA we expect based on their SAT. Okay, do we expect every single person to be on that line? No. Okay, but there might be a few people, or the line might go through some actual data. It might not. Okay? Okay, so question number 5. Any questions so far? You guys okay? No complaints? No tears? Okay, cool. Question number 5 says, what do you use to predict the GPA of a randomly selected freshman if you had no SAT information? So assuming this is either a really good, like, representative data set, or assuming this person is actually a part of this data set, they might walk up to you and say, hey, what do you think my GPA is? Freshman year of college. If you don't know this person, you say, well, what was your SAT score? And if they say, I'm not telling you, or I can't give you that information, what is the best number that you can use to predict their GPA their freshman year of college? Just the average. Whether they look average or not, that's your best guess. Okay? Now, if you know this person, if you know anything about this person, if this person brags a lot about their really high test scores, then maybe you want to bump it up a little bit. Maybe you want to be all judging. If they look a little nerdy, maybe you bump it up a little bit. If they look a little bit like they spend too much time staring at an Xbox instead of doing their homework, maybe you want to drop it down a little bit. I don't know. Yeah? If they can't even hold a conversation with you because they can't look away from their phone, go ahead and just drop it. Like a whole point. 1.9 for you. Yeah? But with no information, with no extra information, our best guess is just going to be average. Now, what is the give or take on that guess? Do you guys understand what I'm saying when I ask that question? Like, how far off are you going to be? Yeah? Okay. Yeah, whatever the standard deviation is. Okay, when you take this as your guess, this is your error. When 2.9 is your best guess for somebody's GPA, then that give or take is 0.4. It's the SD from that original data set. Notice, when I was conversing with this make-believe person about their freshman year GPA, they never, ever, we never even talked really about their SAT score. I asked, but she wasn't willing to give it to me. So this data up here means nothing. Also, this doesn't really mean anything either. It doesn't matter how tight the correlation is. If she's not going to give me that information, it won't help me even if it's a perfect correlation. Yeah, so all I have is this right here. All I have is data about freshman GPA. That's all I can use if I don't know anything about her SAT score. So I predict 2.9, and my error is 0.4. So my guess is, I think your GPA is about a 2.9, but I'm probably off by about 0.4. So really what I'm saying is I think your GPA is probably somewhere between 2.5 and 3.3. But I could still be off, right? That's just the error. That's how much I think I might be off. But I could be off further than that. Yeah? Okay. All right, so we should be done with the front page. So look at your front page. If you haven't answered any of those questions, fill them in. Number 6 is the 0.4. Sorry, it's called RMS error. We didn't actually, so the RMS error, do you remember root mean square? Do you remember when we used that? I told you it was the stupidest acronym because number 1, it's backwards, and number 2, it doesn't include all the steps. That's when I taught you that, it's when we were trying to find standard deviation by hand. Okay, so standard deviation is an RMS, and we call it RMS error because we're trying to see how far off our guesses are. But on your formulas page, your blue piece of cardstock that I gave you, there is a formula for RMS error that's more complicated than just standard deviation, but we're not using that one right now. We only use that one when we're actually using the regression line. We didn't use the regression line to make a prediction that her GPA was 2.9 because she didn't tell us anything about SAT, so we couldn't use it to help us. Now, on these predictions, either of these, did I use the regression equation? I didn't actually come up with the regression equation, but did I have information about SAT to make the prediction about GPA? My guess that someone's GPA was a 2.72 was based on the information that I was given that person scored a 430 on the SAT. So when I'm using this data to predict this data, then you use the RMS error that's on your formulas page. When I don't have an SAT score to predict the GPA, my RMS error is strictly just straight off of that data set. It's just that SD. Okay? All right, now where we get to the actual, this is what I really want you to be doing. Okay? That I want you to understand. I hope all of that makes sense to you. I get to assume that it does because you didn't ask any questions. So my assumption is that you know everything perfectly. Okay? Well, neither does the silent treatment, so I guess you'll get over it. Okay, all right. All right, so number 7 asks us to find the regression equation. Okay, this is where you may or may not have to rely a little bit on your formulas page. Your formulas page will be here for you, and I gave you the formulas in the order that you actually need to use them. So we're on test number 2. UVU only does 4 tests, so even though we've had more tests than that, this information is test number 2 from UVU. Okay? So, question number 7. Oh, yeah. I was like, I know a lot of Taylors. Right here. Cute. Thanks. Okay. Where was I? Oh, yeah. Formulas page. Okay. So, the regression equation. This is the most popular thing we do in this whole entire unit. Okay? That's why those are the formulas that are on your page. So, what is the first thing it tells you to do on your formulas page? Do you know this information? Do you know all of those variables? Can you put numbers in those 3 spots? Okay, do it. What's SDY? The standard deviation of the Y variable, which for us was the GPA, so that's the 0.4, divided by the standard deviation of the X's, which was 80. Throw that in a calculator and tell me what you get. Don't freak out when it's tiny. Is that the GPA? I mean, is that the slope? That's what I meant. Is that the slope? Assuming our multiplication and our division went fine. Yes, that is the slope. What does that slope mean? So barely moving. But what are the two variables? Let's talk about units for just a second. 0.45, your R value does not have units on it. Okay? It's a measurement of how close things are, but it doesn't have units on it. 0.4 is a what? That's your GPA points, right? So 0.4 GPA points over 80 what? Yeah. So 80 like SAT points. So our slope, if we put those units together, is kind of like GPA points per 1 SAT point. So interpreting the slope, if your SAT score is 1 point higher than the person sitting next to you, I anticipate that your GPA is 0.00225 higher than theirs. You see how it doesn't even really make a difference for 1 SAT point? I don't even know if you can score 1 point. I don't know exactly how SAT works. But it makes more sense to talk about it in like 10. So 10 extra SAT points gives you a GPA that's 0.02 higher. So like from a 3 to a 3.02. Yeah, or a 3.98 to a 4.0. That's a super important 0.02 difference on your GPA. This could be super powerful. Yeah? Or a 1.98 to a 2.0 if you have to have that 2.0 to get your eligibility or whatever it is you need. Yeah? Okay, so 10 points on the SAT, 10 points higher, you can actually see the difference on the GPA. It's dramatically higher if we talk like 100 points on the SAT or 400 points on the SAT. Those are going to be differences we're actually really, really, really going to be able to see in the GPA. But we all know that teeny tiny little differences in GPA are really big, like for scholarships and for admissions and for your future. Okay? So that's why this number is so small, is because it's the change on your GPA. And GPA only goes from 0 to 4, not a whole lot down in the 0 range. Yeah? So there's just not a whole lot of spread. There's not a ton of variability in GPAs. Okay, next question. Oh, number 8. Interpret the slope of the regression equation. So we just found the slope. Interpret it. How do you put that in your own words? Somebody tell me what you're going to write. Interpret the slope. What are you going to write? Put it in context. Okay, I'm telling you right now, if you say rise 0.00225, run 1, that's bad. When I say interpret, I want you to use words like SAT and GPA. So how do you use words like SAT and GPA to help me better understand this number? What is the significance? But, no, you can use numbers. The rise in your what? GPA is 0.00225 for every what? For every 1 additional point you earn on that SAT. Okay? And really, to be honest, this data isn't about you improving your GPA or improving your SAT score. It's really about comparing you to somebody else. Okay, because at this point, the data is already set. So it's kind of sort of saying, if someone scored an SAT or SAT score 1 point higher than you, we anticipate that their GPA is 0.00225 higher than yours. Okay? Most of the time we say this. This is the phrase we use. For every increase of 1 SAT point, we expect an increase of 0.00225 on the GPA. Yeah? Okay. The next thing that it asks you to do is interpret the y-intercept. Do you know the y-intercept? No, we haven't found it yet. That's next. Look at your formulas page. After you find slope, what are you supposed to do? If you look at that blue formulas page, once you're done with slope, what comes next? Yeah. Two options for finding the equation of the line. I usually do y equals mx plus b. Today I'm going to make you do y minus y. I'm going to use the point slope form because I want you to understand that it actually truly is easier, but some people just don't believe. So the actual equation is already on your formulas page for you, and it says, I'll show you right now. Yeah, it's fine. Okay, so when you're using point slope form, it's designated, like it's designed for you to insert a point and insert a slope. What is the point that we're inserting? Whether we use, whichever formula we use, it doesn't matter. What is the point, the ordered pair from this data set that we are going to use? The point of averages, the 5, 10, and 2.9. Okay, so for us, if we're using this form, we put those right here. 5, 10, and 2.9. Is there any other information that we know about this line besides the fact that it crosses through 5, 10, and 2.9? The slope. And where does slope go? M. So this is 0.00225 x minus 510 y minus 2.9. So all you do if you're using this form is replace x1, y1 with x bar, y bar, or the point of averages. Okay? Now we just got to make it look good. Like distribute, get y by itself. So I distribute, I get 0.00225x minus whatever that is. Does that look right? I want to get y by itself. How? Add 2.9 to its like term over here, so that y equals 0.00225x plus what? 1.7525. I never once said anything about finding the y-intercept, but that was the next problem on the worksheet, was to interpret the y-intercept. Did I find it? Yes. I did two things in one. I found this whole thing, which this is what we call the regression equation. you can find, for every data set that I throw at you, if you can find a regression equation, you are probably 70 to 80% done with every problem you have to do on this next test. If you can do that, you are golden. The rest of it is basically just understanding and interpreting stuff. Okay? So here's your regression equation. Did I also find a y-intercept? Yeah, once I rearranged, I used point slope form, but once I rearrange it, I have a slope and a y-intercept. I put it in slope-intercept form. It looks like y equals mx plus b. Okay? So my y-intercept is 1.7525, and it wants you to interpret that. Again, explain things in context. So tell me what the heck 1.75 is in terms of SAT scores and GPAs. What is that number? Okay. Is that possible? It is possible to be lower than that, but why in this data set does it not go lower? So let's look at this. All those dots are the people, right? So that is saying that this line crosses right here at 1.7525. There is a very distinct explanation, a very specific explanation that I need you to give for this y-intercept. And it has to do with the ordered pair. What is the ordered pair right there that I just drew? 0, 1.7525. What's the 0? 0 what? 0 points on their SAT. Which, as far as I recall, means you didn't take it. You can't get a 0. Just like I don't think it's possible for you to get a 0 on the ACT. I really don't think it is, because I've known some not very intelligent people in my career, and nobody ever gets a 0. You'd have to know all the right answers so you never select them. Right? See? So it's basically like getting a perfect score. Or close. Anyway. Except there are 3 not right answers and only 1 right answer. So, luck of the draw, I guess. Anyway. Okay. So the interpretation of the y-intercept is simply, we anticipate that a person scoring 0 on the SAT would have a GPA of 1.7525 in college. Yeah? Does that data make sense? Not really. I don't think an SAT score of a 0 is a good predictor of anything. Because I don't think you can get an SAT of a 0. Yeah? Do you think there is anyone in this data set that scored lower than a 1.7525 on their, or has a GPA, sorry, lower than 1.7525? What about this person? Did they score lower than a 1.7525? And this person, and this person, and this person, and this person? Yeah. You can have a GPA lower than that. That's just where this regression line happens to cross the y-axis. Lower than 1.7525? Well, straight D's is a 1, a GPA of a 1. Well, it depends. In college, you kind of sort of have to get C's in most of your classes in order for them to count for anything, which is kind of, why isn't it just C or you fail? I don't know. But there are very few classes in college that you actually get credit for if you don't get at least a C. Anyway. Okay. So, did you interpret this? Did you write something down on your paper? Okay, now questions 10, 11, 12, and 13. You do the exact same thing on all of them. What is it? What do you do? 10, 11, 12, and 13. What do you do? Plug it in. You plug in there what? You plug in there, what's your input for this function? When you look at this equation right here, what goes here? What do you plug in? What's x? Wait, what? Yeah, so regression, okay, so your regression equation looks like this. This is from number 7, you should have this. We got the y-intercept and interpreted it on number 9. But this regression equation, this is what we're using for number 10, 11, 12, and 13. And how are we using this, guys? This is super important. How do we use this? You just plug stuff in. Plug it in where? X. So you're plugging in SAT scores, and what is it going to spit out for you? GPA. Okay? So if you plug in, do you guys all know how to do it on your calculator so you don't have to type in the numbers every single time? So let's plug in the first one. What's the first number? 590. So if I do 0.00225 times 590 plus 1.7525 and I push equals, what's the answer? A score of 590 is expected to have a GPA of what? 3.08. Now, on your calculator, if you just arrow up 2 times and push enter, it'll type that. It'll give you that same thing you typed in. You can just arrow over and change the 590. So what are we plugging in the second time? Oh, you have to use entry. Okay, so the TI-83s, instead, if you want to repeat what you typed in before, you just push second enter, which just retypes in what you had before. Then you can use your arrow to go over and type over the 590 and make it a 430. An SAT score of 430 predicts a GPA of what? 2.72. Did we already know that? Guys, we already did this problem. It's right here. We just did it a different way. We didn't just use the regression equation. We didn't come up with the regression equation. We just used the slope, basically. Yeah, for 1 SD of x, we get r SDs of y. We just use that over there. Okay. Next, we plug in what? 510. And what does 510 spit out? 2.9. Did you actually have to use the regression equation to find that one? No, but usually when we get kind of in the middle of the math, we forget. We don't look at 510 and go, oh, that's average. The output is average. So we just plug it in, and then all of a sudden we're like, oh, yeah. Remember how I already knew that? Okay, and then a 700, what do you think it's going to be? I hope it's 3.33. Otherwise, we definitely did something wrong. That's fine. Yep. Good. Does everybody understand where I got these from? Most common thing I'll ask you to do, come up with the regression equation. So, find your slope. Write your equation in y equals mx plus b form so that you also have your y-intercept if you didn't have it before, which you weren't ever given it. You just have to find it. And then plug numbers in. to make predictions. That is the whole point of this line, is so that you can make predictions. Yeah, the regression equation we did forever ago where we were putting our hands in and grabbing the starburst out. I wanted to be able to go measure Mr. Meyer's hand, plug that number in, and be able to make a good prediction of how many starbursts he was going to be able to grab out of that bowl, because apparently that was super important to me. That makes sense? That's how this works. Okay. One more question, because we don't do number 15 until after the break. What is the RMS error associated with all of these estimates? How far off are these GPAs from that person's actual GPA? You have to think of each of these numbers as a person. I met someone who scored a 590 on the SAT, plugged it into my equation, and guessed that their GPA is a 3.08, but they have a GPA. They know their GPA, and then they're going to tell me how far off it is. It's smaller than 0.4. Can anybody tell me why the RMS error now, with what we just did, is going to be smaller than when I didn't know their SAT score? That was my RMS error before, right? 0.4. Does it make sense to you that my predictions should be better when I have more information? Yeah. I mean, just think in general. If someone said, how many siblings do you think I have? Well, if they give you a little bit more information, you might be able to make a better guess. Well, what does your mom drive? Just a Honda Civic. Okay, you have one sibling, maybe two. You don't have 7 siblings because you don't all fit into a Honda Civic. Does that make sense? More information means my guess is going to be a lot closer. So the RMS error formula that's on your formulas page, find it, says that error we had over there, that 0.4, that SDY, is going to get multiplied by this. And believe it or not, that whole square root of 1 minus r squared, that's just going to be a decimal. So when I take a number like 0.4 and multiply it by a decimal that's less than 1, do you see how it's going to make the number even smaller than 0.4? Okay, so do it really quick. 0.4 times the square root of 1 minus 0.45 squared. If you did not get that, check the way you typed it into your calculator. You should get 0.357. Okay? And a way you can check yourself on this question when you're doing it on a test or something, if you plug those numbers into your RMS error and it's not smaller than the original SD for the Y's, then you did something wrong. So, before our GPA guesses, we're going to be off by about 0.4. Now our GPA guesses are off by about 0.35 or 0.36. Okay, so it gets us a little closer. We're just guessing that our estimates are a little more accurate only because we're using their SAT score to help us make that prediction, because we have more information. Good? Does everybody feel a little better now? Yeah? Okay, cool. So you still, if you haven't done your yellow packet, you still need to do that. If you have stuff that is done, feel free to turn it in the basket. You don't need to submit those on Canvas, the yellow, green, or that old pink one. If you have those done, go ahead and turn them in the basket unless you want to keep your green one with you while you work on your yellow one. But again, those all just need to be turned into the basket, not submitted on Canvas. Only the numbered ones need to be submitted on Canvas. Okay?